Welcome to a presentation of data warehouse questions from Database Information Retrieval Systems Assessment 4.2. So what does it mean when a data warehouse is non-volatile? In a data warehouse, the data is non-volatile because the data is not removed nor deleted, or can it be changed. The data is read-only. However, data can still be added to the database in order to grow a historical data source. The reason for this is because the data warehouse is to provide analytics to business leaders and others to make business decisions. Therefore, in order to do analytics, see trending, and to do predictions, historical data is needed, and its integrity must stay intact, thus the need for it to be unchangeable, or otherwise known as non-volatile. What is a fact table in a data warehouse? A fact table is a core table of a data warehouse design that provides the list of summarized data points that will be analyzed. A fact table is also generally referencing a verb. So in this example to the right, you see that the fact table in the center of this structure is the orders table. The fact table is generally surrounded by related tables, which are called dimension tables, which show the diverse ways that the data in the fact table can be analyzed. Dimension tables generally reference nouns as well. So in the example to the right, you can see that the dimension tables are customers, addresses, products, and order items. The fact table also contains foreign keys to relate back to those dimension tables so that data can be referenced. And the overall structure that you see on the right-hand side of the fact table and the dimension tables is known as a snowflake, or star schema. So when do you use OLAP? First of all, OLAP is known as an online analytical processing software. You generally use OLAP when you're looking to organize large amounts of data for complex analysis. You can analyze data from multi-dimensions versus just a one-dimensional analysis, say in an Excel document. You can use the tool in order to answer business questions or predict future business results. So for an example, you could use an OLAP tool to find sales information from previous quarters to predict budgets and to predict product demand for an upcoming year. What are the three types of actions that users perform when using OLAP software? There is the drill down function, the roll up function, and slice and dice. So to get into these a little bit more, drill down is just that in itself. You're drilling down to a lower level of data into more detailed data within an OLAP cube, which is otherwise also referred to as increasing a dimension. So for an example, in drill down, if I'm going from Q1 sales totals to sales information by month, that would be drilling down. The opposite of that is roll up. So this is going up levels of data in order to consolidate, aggregate, or summarize the information further. So for example, if you were interested in the overall Q1 sales totals, instead of looking at the individual months, you would roll up to a quarter view. And then slice and dice. Slice and dice, you can either take a slice or a dice of the data within the OLAP cube for further analysis. Either one creates a subcube for further analysis. The slice is known as looking at a one dimension of the data versus a dice means multi-dimensional analysis of the data cube. So for example, a slice could be looking at a full year of sales, and you look to Q1 at what the salespeople are selling in Q1. If I were to take a dice of the data, that could mean that I'm taking the data from Q1 but looking at more than one dimension. So for example, I'm looking at the salesperson and the sales amount within that quarter. What is data mining and what are the approaches to data mining? So data mining consists of processes to find new data, new trends, or patterns from data in a data warehouse or a large amount of data. It's digging into that data to find new things, how to paint new stories, how to understand new ways that we can leverage the data. That's generally using software that leverages algorithms and that uses new ways of looking at the data that a human would not be able to do manually due to the sheer size of the data. The different approaches can be classification, association, outlier or anomaly approaches, clustering, regression analysis, prediction, and sequel patterns. And lastly, what are examples of data warehouse technologies at Amazon? Amazon has a large amount of data in order to be able to facilitate and fulfill orders quickly. They have a vast data warehouse system that allows for quick referencing of where certain items are in their gigantic warehouses for their pickers to be able to get to the order items very quickly and efficiently in order to be able to get them on the line for fulfillment and shipping out to trucks. So Amazon already has a large data warehouse that they leverage and a lot of tools that they also have for customers to be able to leverage within their overall AWS platform. More specifically, Amazon Redshift is a data warehouse tool that Amazon provides and utilizes themselves. It can leverage existing BI tools and software to analyze data further. That includes MySQL Workbench, Tableau, MicroStrategy, Amazon QuickSight. There are also other data warehouse technologies that Amazon has and can leverage, which is known as Amazon Athena, Kinesis, Amazon Relational Database System, Dynamo Database, and last but not least, a slightly newer version, and this is not a data warehouse, but it's a new technique. It's called a data lake. Again, it's not a data warehouse. It's a way to have a centralized, normalized central location for all of the data. And tools such as Amazon Redshift can actually pull data in from those data lakes in order to be able to do further analysis.